continuing with round 2 of projectile motion for today. We have a similar application. You have the biker, and if you're still at the biker, you can come right next to it, and you see Archer. This is your chance to be Robin Hood. Robin Hood was a fantastic archer, and this is your chance to do the same. You need help from your friend Toodles, who's over here. The moment you say go, Toodles will drop that coconut, and you will fire your arrow. Your goal is to hit the coconut. Now, we have similar things as we did with the biker. Simulation speed does the same thing. It slows down the speed at which the events are going on. I like this to go nice and slow to make sure it adds a little more excitement. You have an angle that's, as you can see, the angle with which the archer is aiming. And you have a height. The height, not something you had on the biker, the height adjusts Toodles' height. Toodles' branch height. You can go up, you can go down. And your task is try to hit the coconut. When you have it set, you think you can do it, you say, go! And I was unsuccessful. But again, you can see the nice path. You saw the coconut drop straight down. We saw the arrow go. We can reset. We can do step by step, just like we were doing with the archer. To see frame by frame if you would like to. And again, just like the archer, you can show the axis, or just like the biker, you can show axis, and you can see the horizontal and vertical distances. Along with that, there's also the velocity vector, the acceleration vectors, and the velocity and acceleration vectors. They were not entirely necessary for the biker, but for the archer they will, because I want to ask you a few challenges. First of all, play around with it to see if you can hit the coconut. And if you can, see if you can do it 3 separate height angle combinations. Then I want you to look at the acceleration vectors of both the coconut and the arrow, and explain what you see and why you think that is true. Then I'd like you to look at the velocity vectors, both in the y direction and in the x direction. You can see the velocity. The red is the x component and the y component. Blue is their resultant. See what you notice about those. Little challenge to figure out what's the minimum velocity you can hit it. And then the generic question, if it's possible, where do you have to aim so that you can strike this coconut every single time? No matter what the height or is, you can set it up where you'd hit that coconut. Those are your challenges. They're all on the PDF. Good luck.